Can a mountain be turned into a plain? That's really the topic in this video, which is weathering, erosion, and deposition. Weathering is breaking down a larger rock into a smaller rock, which is called sediment. This is from page 6 of your reference table. This shows that the smallest sediment is called clay, and as you work your way up, the largest sediment is called a boulder. If you look on the left side, it shows you the actual diameter of each of these sediment particles. And be careful when you read this, because it's a logarithmic scale, which means that you have to very carefully count the increments to see what the values are. There's two kinds of weathering. Mechanical weathering is the physical breakdown of rock into smaller pieces. This is typically associated with ice wedging, plant root wedging, wind, falling rain or snow, heating and cooling rocks, and then finally gravity. Chemical weathering is when a chemical reaction changes the chemical composition of the minerals in the rock. And this typically happens through acid rain or through oxidation, which is another way of saying rust. An example of a rock like this could have been caused by mechanical weathering by ice. This is where water seeps into a crack, it freezes and expands, and then it can split the rock where that crack was. This is an example where a plant root has wedged its way between a crack and a rock, expanding the crack. This is an example of chemical weathering by acid rain, where acid dissolves limestone and can create formations like this. And then we also have an oxidation. We also have a chemical weathering by oxygen. And you can see here this is one rock, but it has this crust around it where it has been oxidized. The smaller the sediment size, you increase the surface area, and the larger the surface area, the rate of weathering increases. So the smaller pieces of sand are going to weather a lot faster than a larger block, like in this example here. Weathering is breaking down rocks into sediments. Erosion is transporting sediments from one place to another, and deposition is dropping off sediment. We're going to consider 5 environments: a slope environment, a stream environment, a glacial environment, a sandy desert environment, and an ocean shore environment. The basic rule for slope is that all sediment is eroded downhill. This can happen very gradually, and it's known as creep, or very suddenly, as in a landslide. Streams carry sediment as they flow. The stronger and faster currents carry bigger sediments, and when the current slows down, it deposits the sediment, and it's sorted by size, which means that the biggest sediment is dropped down first, and then the smaller sediments are dropped last. Completing this chart from page 6, you can see that if we pick a velocity, let's say 5 centimeters per second, you follow that line up to where it meets the curved black line, and then you follow that over to the left, and you can see that this would make a sediment. This could move a sediment that is up to 0.1 centimeters, and that's in the category of sand. Streams change speed many times as they move across a landscape. So the first way this could happen is if you change the slope of the landscape, and basically as the slope decreases, it becomes flatter. It first drops off the heaviest particles, then the lighter ones, and then finally the lightest ones. So first the gravel, then the sand, and then the silt and clay. When a stream slows down as it enters the ocean, deposition can pile up, forming little islands called a delta at the mouth of a river. The other time streams change speed is when they turn. You can see here that the eroding bank is the outside of the turn, and the depositing bank is the inside of the turn. We're here at Marcus Park in Honey Eye Falls, looking at this meandering creek to see how the meanders affect erosion and deposition. So the bend in the creek here, the meander in the stream, this is what we call the outside bend. And this is where it's actually cutting away, and you can see on this side it's very steep. So the water is actually cutting away at the outside bend, and on the inside bend across the creek, you point it over there on the other side, you can see how it's a lot more gradual, and that's where the sediment is being deposited, so it's going to fill up on this side. Now if you watch me here, I can actually show you this side is slow. I'm just looking down. the deep side. Woo! And as I walk across, it's going to be getting more and more shallow. Getting shallower and shallower as I cross over here. Walking across. So again, I walk down. And this is where the water's cutting across, right over here. Alright, let's take a closer look at this outside bend. Okay, this is the outside bend of this meander that we just saw. And over here, that's the inside bend. And the other thing I wanted to demonstrate here is that the water on the outside bend is actually going faster than the water on the inside. So if we compare, if I put a leaf here, you can see it moving on the outside bend, and we get a sense of how fast it's moving. And if I cross the creek here over to the inside bend, and I take a similar leaf, and we watch, we can get a sense that it is moving a lot slower than on the outside. So as you saw in the video, the outer bank is where the water is moving fastest, and that's where it's eroding, and it's going to be deeper water. And the inner turn is going to be where the water is moving slower and depositing sediment, and it's not going to be nearly as deep. A meandering river can turn into an oxbow lake if that meander keeps getting more and more bent. And there's a diagram here that sort of illustrates how that can happen. The third environment we'll consider is a glacier. And this is very different because sediment is just scraped up like a plow, and it leaves masses of unsorted material, which means it has lots of different sized rocks all piled together. The end of the glacier is called the end moraine, and that's just a huge pile of sediment, unsorted sediment. In this map here, you can see that that red line represents where all of the terminal moraine was deposited by the glacier. And if you look very closely at the southeast part of that, you'll see that the terminal moraine pile in the ocean there is actually Long Island. Other features that are left behind by a glacier can be kettle ponds and finger lakes, which is where the glacier gouges out an enormous hole in the earth, and then when it melts, it leaves behind a lake or a pond in that hole. Other glacial features can be an erratic, which is a giant boulder that's carried by a glacier and deposited in a seemingly random location. Glacial till is any unsorted sediment left behind by a glacier, which is much of what the topsoil in New York State is. A V-shaped valley is caused by a river, but a glacier causes a U-shaped valley. The fourth environment is a sandy desert. Here we have sandstone that has been eroded by wind, and on the bottom we have loose sand which is turned into a dune. This diagram shows that wind can blast sand, causing abrasion on rock surfaces, which can sometimes create arches and other pillars and things like that. And if the sand is loose, it can create different kinds of dune formations which can migrate across a desert. The fifth environment that we'll consider is an ocean shore environment. Now, basic motion of water here is back and forth on the beach where the waves are, but there's also this thing called the longshore current, which is where it moves sediment in one direction up the coast. In our part of the world, you can see in this red arrow, all of the longshore currents are going to be moving towards the northeast up the east coast. But in other parts of the world, that's not necessarily the case. So here's a map of the east coast of the United States, and you can see that all the sediment would be moving up the east coast toward the north. In this diagram here, you can see that the land is the dark part and the white is the water, and which way would the longshore current be moving? This arrow is the answer. You can see the way that the sandbars are pointing toward the right means that the sand was being deposited in that direction. So it's basically being eroded from the left and being deposited towards the right direction.